Let's talk about maps, which are the second most important type of collection in Scala after lists, of course. Maps, like lists and sets, are a part of the core collections module in Scala. These are immutable associative containers. Associative because they contain key value pairs. In fact, maps can best be understood as a set of key value pairs. The implication of that is that each of the elements, each of the key value pairs inside a map can be thought of as a pair, a tuple with two elements, the first of which is the key. Of course, the handy property of maps is that the key can be used to look up the value. That's why they are known as an associative container. Let's dive into a simple demo in which we will run through the operations that programmers commonly perform using maps. Creating them, of course, using keys to look up values from a map, invoking higher order methods on a map, that is, having a function object operate on every element of a map, and of course, converting lists to and from maps. Let's start with a look at how maps are created. What you see on screen now is a value called state codes which has been assigned a map. And as you can tell, on the right hand side of the assignment operator is a map followed by a set of key value pairs. That is a map created for you. The key value pairs that we've specified are all in the form of two element tuples. Remember that two element tuples can be created in one of two ways, either using the arrow notation, which is what has been used for the first two tuples. The third key value pair, the one for Vermont, uses the alternate syntax of two strings enclosed between a pair of parentheses. The resulting object is a scala.collection.immutable.map, and the key type and the value type are both string. Scala's type inference has figured that out. Once we've created a map, the next obvious thing for us to do is to go ahead and look up a value by specifying a key. If that key is present in the map, the corresponding value will be returned. In this case, that's the string VT, which is the state code for Vermont. What if the key does not exist in the map? Well, this is an important question. The result will be an exception. This is important and we will return to it when we talk about exception handling in Scala later on in this module. But for now, remember that if you try to look up a key that does not exist in a map, the result is an exception. An exception will be thrown and you should be prepared to handle it. This means that it's important for us to know, to check beforehand whether a key exists in a map, and this can be done using the method contains. Here you can see how we've checked whether the map state codes contains the key California. The contains method will return true if that key is present in the map, else it will return false. For instance, here we check whether our state codes map contains the state name Georgia, and the result is false. This is one way of preventing lookups of keys which do not exist in our map. Next, let's move to understanding how an higher order function can be applied to a map. The key to doing this is to realize that a map is a set of key value pairs. So we can specify any function object using the common higher order methods such as for each and so on. The important bit is that within the body of the higher order function, we've got to accept a single parameter, and that parameter will be a key value pair. We can access the key and the value individually by using the dot underscore 1 and dot underscore 2 notation. Here, for instance, we use p dot underscore 1 to refer to the key and p dot underscore 2 to refer to the value. Remember that tuples are indexed starting from 1. This makes them different from collections which are indexed starting from 0. Because of how important lists are in Scala, we ought to know how to create a map from two lists. We have one list representing all of the keys that will be in our final map, and the other refers to all of the values. Here, the keys are a list of states: California, New York, and Vermont. And our values are a list of state codes: CA, NY, and VT. To convert these into a map, we will use the zip method followed by the toMap method. Remember what zip does. Zip will take two lists and create a third list where every element is a tuple of the corresponding elements in the two input lists. We then invoke the toMap method on this list of tuples. This will convert that list of tuples into a map. Converting a map into a list of keys or a list of values is really simple, As you can see, to get a list of the keys, use the methods .keyset.toList. We invoke these two methods one after another, and what we have is a list. By the way, the result of the first method call .keyset is a set of the keys. We then use the .toList method to convert this set into a list. It's equally simple getting a list of the values from a map. Simply use the .values .toList method calls one after another. You can see that carrying out this operation on our map gives us a list of strings CANYNVT, which of course were the values in our original map.